Hi, for this lecture, I will briefly introduce you about scales and units in ecology. So, this will not uh, be a key topics for this course, yet I feel it's good for you to have some fundamental understandings about this concept before we proceed. Okay, in ecology, the scientists has started to recognize the importance of the concept of scale, which is somewhat crucial in the ecological studies. What is a scale? A ruler has a scale. That one tool that you step on to show whether you fat or not has a scale. You can find the dictionary to find the literal meaning of it. You'll know what I meant. But in scientific context, there are a number of scales that have specific functions, uh, including the cartographic scale, okay, which is used a lot in for map. We have ecological scaling to look at the environmental concept or environmental uh, understanding about it, and we have some spatial and also temporal skills. Spatial usually talking about space, and temporal is looking about time. One of these definitions, one of the comprehensive is that scale denotes the resolution within the range or extent of a measured quantity. This definition can be applied to the space and time component of any quantity. For example, if you study leaf litter that fall to the forest floor, okay, so this is one of the study that has been done a lot in ecology, forest ecology. This study might have a spatial scale resolved to the area occupied by a single tree within the spatial extent of a 100 hectare study area. So this 100 area study area is a spatial scale. Okay, how big that you want, how big the space that you want to study. Okay, that's a spatial scale. The temporal scale of the study might be resolved to weekly measurement over 2 years. Okay, so you study the 100 hectare area, which is a spatial scale, over 2 years. Then you collect the sample every 2 weeks for for the next 2 years. So that's the time, which is the temporal scale. This definition can be extended, okay, it's not only spatial and temporal, to any variables regardless of its spatial or temporal resolution range, like temperature or whatever scales that you want to include to explain about your study. Okay, study of one for this case is the leaf litter. These are some of the themes used to study ecology. Okay, you can pause the video, okay, for to read this list and try to reflect which of these themes are close to you, which of these themes that you really, oh, this is something that I usually faced in my real life, or in our study, in your study, in your final year project, for instance. However, some of the key problems of scale in ecology is, these are some of the problems. Because first is because the pressing problems in ecology often at scale of decades and large ecosystems, especially when you study diversity. Time is probably your biggest limitation or biggest obstacle. Okay, because you need to, if you want to study the population of tiger, you cannot study a population of within 1 or 2 weeks. You need decades or probably hundred of years to study, especially if you want to look at a large ecosystem. Okay, secondly, sometimes because of the measurement are usually at scales for smaller than pressing problems, right? Like like we said, like the example that I gave you just now about the leaf litter, you only taking about 100 hectare of land, and there's 100 hectare of land, you will not collect every single leaves of that 100 hectare leaf. You need to do the sampling. So which means that the scales usually at the smaller size of the pressing problems, which is we want to look at the hutan belum. How big is hutan belum, right? How big it is. Even if you go to Rimba Elmu, for instance, you cannot how big is Rimba Elmu, and how is your capacity to do it within the scale of the scale of time. So there's second one. So usually we do the smaller space. uh, but and then the third one, patterns and process prevailing at small scales do not necessarily prevail at larger scales. So of course sometimes when you do the small scale, so you cannot interpret, sometimes it's very prematurely, you cannot interpret the idea of the whole ecosystems. For instance, if you want to look at microbes in the soil, you just take 1 teaspoon. Over that quantity, you can get millions of uh, bacteria inside it. So you cannot extrapolate based on 1 teaspoon to the whole agriculture land for 1 hectare, even up to 1 hectare of land. So these are the key problems of scale in ecology. Despite being saying that, I think you still need to do you need to still to understand in the how to use the scale properly to address what's the problem that we have. Of course, the classic example of the problem of scale is loss of biodiversity. Okay, the cause of species extinction, for instance, uh, occur at the scale of ecosystems, whereas measurement are of necessarily confined to small areas. Okay? Yet, no biologist would try to address the problem by direct extrapolation from local examples, because it is well known that species number does not scale directly with area. It has become increasingly clear that the same principle applies to any ecological problem. So this is one of the example. I just read it from the textbook. Okay. Okay, I think you already learned about the types of measurement scales, which is the nominal, ordinal, interval, and ratio scales. This you already learned in a biostatistics class. Please refer to your old notes to refresh your memory. Okay. Next is units. Units on a ratio type of scale are the basis for scaling. Okay, multi-scale analysis requires ratio scale units because these units can be used to represent the actions of repeatedly halving or doubling a quantity. Zooming in on detail requires units that can be halved repeatedly, an operation that is naturally with ratio scale units but not possible with nominal, ordinal, or interval scales units. So basically units is just uh, okay, I'll just give you how to use the unit. Again, I'm not going into details into this, but understanding how to use the units is equally important in studying quantitative ecology, especially when you want to develop model out of your data. So how do you want to use the units? So you can allow for unit conversion. They can combine to make new units via multiplications and also divisions. So then they permit analysis to multiple scales of space and time. Sometimes the properties of ratio scales units make them useful in interpreting symbolic notation. So of course, these are the standard unit used in mathematics. Combining these different units might give us different meanings or interpretation or different units. And For instance, these are some of the units that commonly used in ecology. The one I always use is all this area. So you see that the combining of different units, okay, can give you different interpretation or different meanings or different quantity, if I can say. Okay. So next, we will discuss a little bit on plant ecology and the principles of objectives and the objectives of samplings. Until we see you next time.